All right, for notes number 6, we're doing adding and subtracting radicals. So this is the last part of unit 0. This is definitely the most complicated one because we need to make sure we have the same radicand. And if I haven't mentioned radicand, that is this. So that's your radicand right there, okay? You can call it radical, radicand, whatever, but it's easier in this sense to say radicand. Okay, so we need the radicand to be the same. So if it's square root of 5 and square root of 3, those aren't the same. We can't add or subtract those. So it's kind of figuring out and simplifying to make them be the same. So let me show you what I mean. So right now, when you look at this problem, they don't have the same radicand. This is square root of 5, this is square root of 45. But this is prime, so we can't simplify this anymore, but 45 we can. So we're going to go to simplify everything first, and after we simplify, we can see if they have the same radicand. So we have 9 times 5, 3 times 3. There's our pair of 3's and our leftover of 5. So you can already see the leftover of 5 is going to be the same as this. So that's exactly what we wanted. There's a 2 on the outside, so you're going to multiply times that pair of 3, and then your leftovers goes on the inside. So we've got 6 square root 5, and then we're going to bring this down and the minus sign down. So minus 2 square root 5. So now that's exactly what we wanted to happen. I'm going to highlight that. So we want this and this to be the same. Okay, so you want these to be the same in order to add or subtract them. So now that they are the same, I can take 6 and then the minus 2. So 6 minus 2, that's now on the outside, and square root 5 stays the same. So it's kind of like when you add fractions. You get a common denominator, and the denominator stays the same. It's very similar to that. So 6 minus 2 is 4, square root 5, and that's our answer. Okay, do a second one here. I'll do it over here. Okay, so you're going to get a lot of bigger ones when we do the worksheet or the check your understanding, like where there's like 4 or 5 things here. So you're going to have to check to see what goes together and what doesn't. Some might just have nothing that it goes with, so it stays on the side, but it's still part of your problem. But we have to reduce everything that can be. So this is prime already, so this can't be simplified anymore. This can and this can. So let's do that. So 12, we've got 6 times 2, 2 times 3. You could have done 3 times 4 as well, so it just depends what you want to do. So we've got a pair of 2's and a leftover 3. We have a negative 3 on the outside, so negative 3 times our pair of 2 with the leftover of 3. This comes down, well, let me do this real fast. So negative 6 square root 3. And then this comes down because it's already in simplest form. Okay, so this is good. These are both 3s, so we're going to be able to add them or subtract them since there's a negative. Here we want to simplify this, so that's 4 times 5, 2 times 2. We've got a pair of 2's and then a leftover 5. So with the 3 there, it's going to be 3 times our pair of 2. Leftover is inside the radical. So that's going to be plus, because of the plus sign, plus 6 square root 5. So we can only add things that have the same radicand. So this 3 and this 3 are good to go. So we can go negative 6 right here plus the 3, and then square root 3 stays the same. We can't do anything to this, so it just comes down. So plus 6 square root 5. We can't add it or subtract it to anything. So this is going to be negative 3 square root 3 plus 6 square root 5. And that would be our answer in simplest form. Okay, so We're going to do a lot of practice with this because it's a lot of steps. It's tedious. You have to make sure everything is reduced first, and once it's in reduced form, whatever has the same radicands can be added or subtracted. And if they don't have the same radicand, then you're just bringing it down part of the problem. Okay?